In this video we're going to be looking at the next subtopic for waves, which is stationary waves. Now stationary waves are also known as standing waves, so if you're ever doing a little bit of research online in Google or on YouTube is brilliant, there's lots of videos on this topic. Sometimes it's stationary waves, but you'll probably find more videos even if you look at standing waves. So all the waves we've kind of been looking at so far are known as travelling waves, in that there's a disturbance at this end. So for example, with the slinky spring, right at day one when we introduced waves, I moved the slinky spring up and down, and what that causes is energy to move from left to right. So some kind of disturbance at this end transfers through the slinky spring or through the rope, and it continues on. And that's what we looked at. We just assume like that it keeps going, and it'd be the same for a light wave or a sound wave. We just assume that they keep going in this direction until they hit something and reflect back, or until they're diffracted or dispersed or something like this. A standing wave is slightly different. With a standing wave, what we have is we have one end here where we cause the disturbance. So we might have what's known as an oscillator. And an oscillator is basically just like a little bar that goes up and down like this, attached to our slinky spring. And at the other end, we have a fixed point. So this might be a piece of string or a piece of rope, but I'll show you other examples where you can get standing waves. And what happens in a standing wave is the disturbance happens at this end, and our wave travels down the string. But because we have this fixed point at the end, when the wave hits the fixed point, what actually happens is it reflects. So what you end up with is another wave which reflects and is coming back against the original wave. And this keeps happening. So we have one wave traveling to the right, the red wave, and one wave traveling to the left or the green wave. Now think about what we've learned already. We have two waves passing each other out. And when two waves are passing each other out, they're going to interfere. So what we're going to get is we're going to get areas where they constructively interfere. And remember, when they constructively interfere, we'll get waves which are bigger. And we'll have areas where they destructively interfere, which means that they kind of cancel each other out, and we have either smaller waves or we have waves that are completely cancelled out. So what you get is you get a certain pattern, and that pattern is known as a standing wave or a stationary wave. But there's a couple of kind of frequencies that you really get a pattern that's constant. For most frequency, what's happening is this pattern is changing all the time. So it might be going up and down here. This is the combined wave I'm drawing now. It might be going up and down here, but then a minute later it might be really low here, and so on. Because just the waves are meeting each other at different kind of times and things like that. So, but there is specific patterns that we get at specific frequencies. And here's an example of that pattern. So here we have two waves moving towards each other, the yellow wave and the kind of grey wave. And you see that they're forming a standing wave. Now there's a couple of things to notice about a standing wave. Hopefully let me draw on this animation. The first thing is, at either end, it's fixed. So at either end we have no displacement. And notice that it never goes higher or lower here. Those points of no displacement are called nodes. But in this case, they're not just at either end. There's more nodes. This is a node, this is a node, this is a node, this is a node. Because always at this point, when the two waves meet, they perfectly cancel each other out. So we have no displacement or nodes. And that's one of the reasons why it's called a standing wave. It's this constant pattern. It's always the same pattern. Now, the other points, and you can hopefully, if you just focus on, say, this point, this line here, you can see that the pink wave is always the addition of the two other waves. And it's really, really hard to see, and I can't pause this, unfortunately, to show you. But no matter what, if you add the yellow and the grey together, you get the pink wave. The opposite then of the nodes are this point here and this point here, or this line I should say, and the same for this line here and this line here. At those points, you always have maximum displacement. So the two waves always constructively interfere to give you a much, much bigger wave. And those points are called antinodes. So you can get different patterns where you could have more nodes or less nodes, and an example on a string would be, and I would show you this in class if we were there. Oh, first of all, you can do this with string. Here's an example of what we do in class. We have our vibration generator or our oscillator, which vibrates up or down, sends the wave along the string, and then our fixed point is at the other end, and we get a wave coming back. So we get these two waves meeting, which constructively or destructively interfere. Now you could attach it up to a slinky spring instead. So this would be kind of transverse wave example, where we see transverse waves, whereas this would be longitudinal wave example. Now this is in your textbook, page 181, which I'll get you to read, but they're just two examples of how you could make a stationary wave, and I would show you them in the lab. Where's it gone? Oh yeah. So just looking at the different patterns you can get then. One thing about a standing wave is, and it's easy to remember this if you remember this fact. Let's say this is just a normal wave. Let's say we have a piece of string and we're forming a standing wave on this piece of string. The different types of standing waves that you can get must always have nodes at either end when it's a string. Okay, so if you want to look at the different patterns you can possibly get, what I do is I draw a big wave out and I'd say, well, I draw where there's nodes on this. Well, these aren't nodes on a traveling wave, but I draw where the zero displacement parts are. And the first possible pattern you could get on the string is this one. Now what's happening here is we're looking from here to here. We've a node at either end. And what's happening is in the middle the particles are vibrating up and down. So it's really hard to show you this on this diagram, but I could show you this in the class. But basically we set this end vibrating, a wave goes this way and a wave reflects back, or a wave goes to the right and another wave reflects back. And they interfere to give us this pattern. This pattern is known as the fundamental frequency. And it's the first pattern that you can get on a string. Now the next pattern you can get, and hopefully you see where I'm going with this, and these are just the different possible patterns you can get. Now remember, how do you get these patterns? But you can control how quickly this is going up and down. So you can control the frequency of the wave that's going in, and different frequency waves, different speeds of this going up and down here will give you different patterns. But we're going to talk about this further in other lessons. This is just a brief introduction. The next pattern you can get is, say, between the next node and that node. So the next pattern you could get looks like this. Now I'm drawing it, but you have to visualize that we have a node here at either end. There are nodes, so these particles are not moving up and down, but here and here the particles are constantly moving up and down. These are antinodes. And you could keep going to see the next pattern. That would be called, this is the fundamental frequency, which is also known as the first harmonic, sorry. So we'll bring in kind of music into this a bit. This one's called the second harmonic. And if I go down, I'll draw one more. Again, we have our string. If our string is a fixed length, there has to be nodes at either end. If we're going to look at the next pattern you could possibly get on the string, it would be from here to here. So we're going to have this shape. So we're going to have three kind of antinodes. So it's going to look something like this, where we have a node here, we have a node here, and all of these points here are our antinodes. And if the first one was the first harmonic or the fundamental frequency, the second one was the second harmonic, this is obviously going to be the third harmonic. So as I said, I can show you this on a string, and I have a little animation over here which shows it. That's basically what it looks like on the string, and you do really get these patterns really clear. So here we have our first harmonic, or our fundamental frequency. This is our second harmonic, and this is our third harmonic, and you could keep going, fourth harmonic, fifth harmonic. But what I'm going to do is I'm going to share a link with you on YouTube where somebody's actually doing this experiment so you can see it happening as well. So that's a brief introduction to standing waves. I just want to give you the definition now. And you want to add this to your note. Standing waves, or stationary waves, are waves of the same frequency and amplitude that constructively and destructively interfere to produce a wave pattern in a confined space. So that's your definition. Now just to explain it, same frequency and amplitude. Well, if you're sending one wave down the rope and it's the reflection of that same wave coming back, it's going to have the same frequency definitely, because it's a reflection of that wave. It's the same wave being reflected. And its amplitude, although it won't be exactly the same, it will lose a little bit of energy when it comes back. So here's it on the way down. So I would say the red is on the way back. It would lose a little bit of energy if green was on the way up and red was on the way back. It would lose a small bit of energy on the way back, but usually it's negligible. It doesn't matter, we can still form the standing wave. The next thing you need to know is you need to know that these points are called nodes. They have an N here for node. These points are called antinodes. So watch this video, which you've done already, but pause it and rewind it and take notes, and use your textbook to help you take notes as well. And I'm going to send you another link as well with a video to watch on YouTube.